Clarence, how are you today? Talk to me, people. I acknowledge my existence. How are you? Great. Thank you for asking. All right. Before I get to the math, I keep forgetting to offer mu alpha theta 2. If you're interested in joining mu alpha theta, this is kind of a hard sell for my daughter. She said, "Why would I pay to tutor people? I'm paying them. I don't, but whatever. It's for the chance to help people, which you don't have to pay to do. But it's an honor society. It'll expand the resume, all that. If you're interested, if you're already in mu alpha theta, is that anybody in this class? Okay. If you're already in mu alpha theta, this needs you to fill out this half sheet. If you're interested in joining, take this big sheet. If you have zero interest, then just pass it to the next person. 10-4? Cool. I'm not sure if that's how Trevor talk works, but go for it. Okay, just to review before we get on to the new, what? We did discontinuity yesterday, yes? Do you remember that, or is just big Monday blur? What are the three conditions for continuity? Part of the definition of continuity, what has to happen? The limit must exist, which implies the left hand, right hand must be the same. Okay, so the left hand, right hand have to be the same. The limit exists. That's one. Next. The point has to exist. F at C must exist. And last but not least, the approach and the point must be the same. Nicely done. Okay, what are the three types of discontinuity? Now, I know whole is nice, and it's true, but there's a more mathy way of saying whole. What is it? Removable discontinuity. Awesome. What are the other two? Jump. Beautiful. That's when the left hand, right hand are different. You're jumping from one branch to the other. That's jump discontinuity. What's the third? Infinite. That's when you see an asymptote, either on one side or both. Okay, good job. Moving on to today. Today is another one of those kind of duh lessons. The big idea of it is a real no-brainer. But the saying it right, at least especially in the AP style, that's where they got you. The idea is not, the concept is not highfalutin and uptight. So it's the intermediate value theorem, which I should have abbreviated next to it, IVT. It is common that you abbreviate this IVT. On the AP exam, you can abbreviate it the IVT. In college, you can call it the IVT. You don't always have to write by the intermediate value theorem, blah, 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 blah. You can abbreviate it IVT, okay? The IVT, in plain old words, though it sounds pretty highfalutin, is basically the idea that if something goes from continuously from A to B, it's got to pass through all the points in between. It can't jump any of those points in between. Just like, what's your name? Ethan. Ethan could not have come from that door to this seat without having passed through this one. It just is not possible, right? You must have passed through points in between. That's the intermediate value theorem. It's used a lot in proof. That's the layman's definition. The actual math definition is if f is continuous. That's important. It must be continuous, and we'll talk about why. If it's continuous on a closed interval with endpoints, then for any y value between the two endpoints, there must be some c that makes that y value in between, okay? Now, using it, like I said, is a great caution. Let me just throw a graph up here real quick. Say I had a graph that went from A to B in a continuous fashion. Doesn't there have to be some place in here, say this is M, doesn't there have to be some point in here where the graph passes through that y value? Not, even if it doesn't go straight there, even if it went wee-bitty-doo, doesn't it have to have some point where it makes that y value or passes through that at least once? Okay, that's the idea, no big deal. Now, must there be a place, for example, let's do an example. This is more of a college-y kind of question, then we'll get to an AP kind of question. Must there be a place or a solution to sine of x equals 0.2 in 0 to pi over 2? And if so, why? Well, this is the work you're kind of have to go into. First of all, you want to know what's it like at the endpoints. I don't, maybe it doesn't have to do that. Let's go with, where is sine at 0? What's sine of 0? 0, okay? What's sine of pi over 2? 1, okay? Oh, you know, I already skipped step 1, dark on it. Can you pretend that, can you just do this with your work like I'm doing? Just move it just like that, okay? Because I actually skipped the first step. Before you even get into this, you say, is this even applicable? Does sine move continuously from one point to another, or does it have jumps? It's continuous, okay? So you need to say that. Sine is continuous. Okay, now the endpoint. Sorry, let's talk about where it's going from and to. And let's see if point 2 is in there. Now we're to where I was at. Sorry, we know it's at 0, the starting point, sine has got a y value of 0. At the ending point, sine has got a y value of 1. As it goes from 0 to 1, must it equal 0.2? Yeah, 0.2 is between 0 and 1, yeah? Are you with me? Okay, so you will say that, look, basically I'm following these ideas over here. First of all, determine if the function is continuous. If so, say so. We did it, yeah? Now determine y at the endpoints and see if what they ask about is between them. Now I know it's going from 0 to 1, and we can say that 0.2 is in that interval. Yeah? Are you with me? Now, answering the question and using the IVT, we could say, therefore, that sine must equal 0.2. Actually, let's say by the IVT first. By the IVT, in other words, we're saying why we say what we say. By the intermediate value theorem, sine equals 0.2. And then this is the part that I tend to forget sometimes. At some point in 0 to pi over 2. Right? And at some point, you could say at some x in 0 and pi over 2. Easy enough, yeah? I just kind of fence it in, see if what they ask about is between the endpoints they give me, and I go from there. This is kind of abstract, so if you're confused, please let me know. We work analytically from an equation. Let's work from a table. This is also very common. Tables are limited in that I'm just getting little snapshots. I don't really, any more than if I got a picture of you, that really wouldn't tell me much about you. It might give me a little picture of you, but it wouldn't tell me a lot. There's a lot of stuff I don't know. Same goes with the table. When you're getting a table, you're getting a very limited view of what that function does. Don't read too much into it, right? That said, we're given some values of the continuous function h of, this should be h of x. Sorry, would you change that? Must there be an r between 2 and 5? Now, that's an x value. That's an x equals r between 2 and 5, such that h at that r has to equal 0. Now, we'll talk about the fancy saying it in a second, but just common sense, just thinking about it. What do you think? Does there have to be a point where h equals 0 between 2 and 5? Why? Because you're going from -7 to 11. Can you go from -7 to 11 without passing through 0 along the way? Obviously, you have to pass through 0, assuming the function is continuous. Is it? It is. They give it to you. Okay. Now, despite the fact they give it to you, you have to show that you know, or that you looked, that you know that's a condition. So even if they say it in the problem, you have to start by saying h is continuous, thereby communicating to the person that, hey, you know what the IVT is all about and what's necessary for it to happen, all right? Now let's go with the endpoints. H at 2 is -7. H at 5 is 11. And so we take the point they ask about. 0 is what they ask about, right? What they want to know is there some place where h must have passed through 0. And so we would say off to the side, 0 is between -7 and 11. You could also say that with inequalities. Negative 0 is, greater than negative 7 and less than 11, if you like. Okay? Now the conclusion, we've met the conditions. It's continuous and it's between, so it has to pass through. By the IVT, there is, now this is where we have to use their wording, their function, their R that they talk about. AP problems, they take off if you aren't in the problem. It's very common that people want to just always use F or always use C. You have to use the ones they give you. So in this case, they're talking about, does there have to be some X of R when put into H that equals 0? So we're going to say there is an R in the region from 2 to 5, or there's an R between 2 and 5. And you can say that it works. Or in inequality. You can say there's an R between 2 and 5, where, or such that, and what am I trying to conclude? Where H of R equals H at that point is 0. And really, that's using a lot of the question back in my conclusion. Okay, I'm just using the same region, answering the question, H equals 0. Are you with me a little bit? A little bit. Okay. Let's see. You try this, please. Give it a go, and we'll see if we're on the right track. By the way, you are allowed to make an assumption. You don't have to prove some theoretical exercise that velocity is continuous. Is velocity continuous? It is. Anybody looking around know who's absent on this one person? Evan who? Lyndon, thank you. Okay, that ready? What do you think? All right, first of all, what's the first thing I have to do? Continuity. You have to meet the condition of continuity. Velocity is continuous. Okay? Next, the betweenness component. Okay? This one requires you to do a little reading between the lines. I know I'm going from a velocity of negative 2 meters per second to 10 meters per second. What does at rest mean? At rest means not moving. Not moving means no change in position of time, which means velocity is 0, okay? At rest implies velocity is 0. Now, I know that at time equal 2, velocity is negative 2. At time equal 10, velocity is 10. Is not, therefore, if the requirement that it must have been at rest at some point as it went from moving backwards to moving forwards, it must have been momentarily at rest at least 1 second, yeah? Okay, as much as you teenage drivers might try to slam it into park from going in reverse, you still are forward, you have to go into pass through 0 at least once. So, velocity equals 0 between here. All right, so I meet the betweenness component to this. Now, the conclusion. By the intermediate value theorem, citing the theorem by which you are justifying your conclusion. What? There must be a time. Continue on, please. You're doing great. Tell me, now when you say there must be a time, say when it has to happen. That's kind of part of the IDT. When must there be a time? In or between? Let's say between. You could use set notation. You could use words between time equal to and time equal 10, where or when b equals 0. Okay? And this one didn't force a variable on you like the previous one had H and R. You had to use those. This is just kind of gray area. So we're just saying. You with me? Any questions so far? Okay. It might be obvious, but just to, I don't want to leave anything unsaid. Why is continuity even a requirement? So would you give a look? This is also meant to give a review of continuity. So in all these cases, I'm giving you 2 points, and the function does exist between them. But I want to show why continuity would be a requirement to saying why, or maybe why not, there must be a place where f equals 3. Does f have to equal 3 some point in between if it's not continuous? Well, let's talk about why continuity is a requirement for that to be happening. What's one type of discontinuity? Jump. Okay. So give me what kind of graph could use these points so that it doesn't pass through 3? What kind of jump discontinuity would be happening so it never passes through a y of 3? I mean, some kind of okay. Now that, let's do that. Now is that jump? I'm going to use this because we're going to need it anyway. Is that jump? No, what is that? Removable. Okay, so that's perfect, thank you. That's obviously one case of why continuity is required, because it doesn't pass through 3 there. The fact that it wasn't continuous allowed it to pass through, to not pass through 3. So how about jump? What could be happening with, think piecewise. When you do a jump discontinuity, you're thinking pieces that don't meet. So what kind of pieces could I draw so that it never passes through 3? Maybe from this one we could go up, okay? And maybe somewhere down here we have that. Now do you agree that that never passes through a y of 3? Okay? What's the other type of discontinuity? This is jump. Infinite. So what kind of graph could I look at? Yeah, an asymptote. Say there's an asymptote somewhere in the middle, and it went up from there and down from there. Does it pass through 3 ever? Well, surely not. So you've got to know that it goes continuously from one to the other. That's why that condition being met is so important. If that condition's met, I don't guarantee a point in between. I could have a point in between, but I'm not guaranteed to have it. Okay? This is important. Are you with me? All right. For the time being, on the homework, I would suggest you use your notes to kind of how is this worded, how is it said, but you want to gradually get away from having to use those notes and be able to do it on your own. All right. So here's the homework, and that's the end of the lesson. Now let's just hit questions on last night's homework, shall we? By the way, if you're absent, there's stuff on the website, or there's stuff under the black basket that we printed out. There should be notes and homework. How you doing, ladies? Good. Here you go, ladies. All right, that IDT homework is due tomorrow. That's normal. Usually the homework is due the next day, and that's true also. All right, let's see how we did. Some of these, it kind of started you off rough. I probably could have started you off easy and built up. I did, sorry. So if you struggled, you're not alone, I can assure you. While I'm thinking about it, eventually 7th hour will come and you can ask questions, but I'm always here 7:05, so anytime you want, please, I beg you, come in before school. After school, I'm usually here till 4 or so come in anytime, please. I'm in and out at lunch, so if you want to come in at lunch, you better tell me ahead of time, because I'm not necessarily always here at lunch. All right, let's go over how we did here. So in the first one, it says find the values, and you might underline for number one, if any, at which f is not continuous. If there is a discontinuity, justify why and identify the type. Now, that really is, I'm asking three questions. There's find where discontinuity or discontinuities exist, identify the type. This actually is a little different than yours because after 7th hour yesterday, I said, man, this is kind of lacking, so I changed it. But we want to do three things. Find the discontinuities if there are any, what type are they, and why are they happening. So for the first one, remember, this is actually number one here. Sorry, this is my new version for next year. That's a little easier, gradually building up, sorry. Number one, this guy right here is number one, yeah? Are you with me? Sorry for the confusion, all right. The minute I see something that I could do better, I change it right away. I probably should have, I used to be in first. At any rate, when you look for discontinuities, you're looking for things that break math, that cause problems to happen. Is there anything that breaks math there? No. I mean, when I see a fraction, I think, oh, maybe 0 in the denominator. But x squared plus 4, can that equal 0? No, not for any real numbers anyway. It's an imaginary solution. So this has no problems. This has no 0 problem, no 0 in the denominator problem. There is no discontinuity. If you look at the graph of that, oh, it feels like it should have asymptotes. It has no asymptotes. It's continuous forever to the left and to the right. And so this has no discontinuities. And so there are the other questions removed. What kind of discontinuity? All right. This is actually number 2 on your homework. I apologize. Okay. So, anybody, what'd you do here? What's the first thing you did to get into the problem? Come on, talk up. Factor. Beautiful. Factor. Okay. When you get a common factor like x over x, what does that mean for the graph? Whole. Okay. So do we agree? You agree that is it x equals 0 or x equals 1? A lot of people say 1. What makes the problem when x is 1 or when x is 0? 0. X equals 0 is the problem. You're getting ahead of yourself thinking, well, after it's gone, 1's left up. Well, that's great, but what caused the problem? The x that caused the problem is 0. Okay. X equals 0 is that, what kind of discontinuity is that? It's removable. Remember, whole's nice, but the actual vocabulary is removable. And going on to the next part, why is it happening? Well, why does it, let's talk, when I said why, I was trying, and badly, I didn't do a great job of it, but to clarify now, I was trying to get you to get into the definition of continuity and tell me what part of the definition is being violated. Is it that the limit doesn't exist? Is it that the point doesn't exist? Or because they're not the same? Well, at a whole, what's the problem? The point doesn't exist. There's a hole there. And so the third part is f at c does not exist. That's why there's a discontinuity. Okay? There's no point there. Are there any other discontinuities there? First time I did this, I kind of just moved, all right, the hole's gone, here we go, number 3, but I missed one. Is there another discontinuity? Yeah, there is. There's another 0 in the denominator. What is it? X equals? What makes this 0? Negative 1/2. Now that's over 0, non-zero over 0. What does that do to the graph? What does 0 in the denominator do to the vertical asymptote? Okay, so what do we call a vertical asymptote? Infinite discontinuity. And there actually, you have a lot of choices here. Why is that a discontinuity? You could go a couple different. Why is that causing the graph not to be continuous? Let's start with the first one. Does the limit exist? No, and that's actually because the left-hand, right-hand approaches to that asymptote are different. So you could say it's a discontinuity because the limit d and e. Does, at a vertical asymptote, does a point actually exist? No, you could also say number 2, there is no f at -1/2. The graph has an asymptote there, so you could go there. And then obviously 3 is there too. They're not even existing, so they can't be equal. So you have a lot of choices for that side. Now, again, I apologize. The directions weren't super, so if you weren't quite sure what I was getting at, then that's my fault. I apologize. But next year, they'll have no problems. All right. 3. Number 3. I debated. I sat there staring. I thought, should I just work with it the way it is, or should I get a common denominator? And it turns out you get the same answer either way. I did it both ways, and it's the same. So tell me something that's a problem here, that breaks math, and causes me a problem. What? X equals 0 is obviously a problem for this one. What's going on there? Vertical asymptote, which means what kind of discontinuity? Infinite discontinuity. And why would an infinite discontinuity cause, why does infinite cause a discontinuity? It's because the limit dne or f at c dne or what? F at c dne is a good, easy one to go. At a vertical asymptote, there is no point. I can't put in 0. Okay? So there is no f at 0. I should actually say f at 0 dne. Do you agree? Any others? 1. At x equal 1, what's going on? Vertical asymptote or polyhole? Pole. What kind of discontinuity is that? Removable. And that's a discontinuity because why is there a discontinuity at a hole? Is it because the limit doesn't exist or because the point doesn't exist? Point doesn't exist. F at 1 dne. Anything else I'm missing? X equals -1. This is factorable into x plus 1, x minus 1. X minus 1 is common, so it's a whole. But x plus 1 is just a 0 in the denominator, not 0 in the numerator. So that's a vertical asymptote. X equal -1 is also infinite. F at -1 dne. All right, last but not least, a piecewise. How do you go about seeing if a piecewise is continuous? You really have to do that first question. We need to see if the limit exists because the left hand, right hand are the same. Take a look at your work. This is often a source of lost points on an AP test. People want to boil it down to, I would actually see stuff like 11 equals 7 plus 4 equals 11. That's true, and I kind of know what you're doing. You're kind of saying this at 4 and this at 4, they got to be equal. That's great, but that doesn't really show the definition of continuity. So in order to get a good habit, when you do this, would you please use limits? It's actually in the rubric for the AP grading. Uses limits to find continuity. If they don't see limits, they don't even read it. They just pass, put a 0 on it and pass on. Okay? So the limit, as x approaches 4 from the left, now, I'm going to do this by the book. Of f of x needs to limit equal the limit as x approaches 4 from the right of f. True perfect world math, you should start by saying the limit from the left equals the limit from the right. Then, again, perfect world math, when there's a piecewise, you then say or specify which piece you're using. So, for example, this first left-hand limit, I'm using the function 2x plus 3. And for the right-hand limit, I'm using the function 7 plus 16 over x, yes? Okay. What is the left-hand side? As x approaches 4, 2x plus 3 approaches 11, direct substitution. What about the other guy? As x approaches 4, the other guy approaches 7 plus 16 over 4, which is 11. What did I just show? Did I show continuous yet? I showed the limit exists. Okay, all I showed is part 1. The limit exists, the left hand, right hands are the same. All right? Now I need to say f at c exists. What is f at 4 equal? I could say the limit exists. Boom, that's good. Does f at 4 exist? Yes, okay. On a piecewise, you're just looking for, is 4 defined, all right? Does it equal 4 sometime? Does it tell you what to do when x is 4? It does. When x is 4, it tells you to do this. What is f at 4? 11, okay. Now, are those the same? They are. And so we conclude that it is, f is continuous at 11, or x equal 4, rather, sorry, right? Are you with me? Okay. Now, is there anything else I need to consider? I definitely looked at the meeting point because on a piecewise, that's the start of the show. But don't I also have to look in the body of the graphs on the side? So 2x plus 3, is it continuous everywhere? Yeah, it's linear. Okay, what about this? Is this continuous everywhere? It's not continuous at 0, but that's okay because x is greater than 4 for that branch. So I'm not really I'm not around that asymptote, okay? X equals 0 would be a problem, but I don't use that function for x equals 0. So as far as x equals 0 is not an issue because this is only for x greater than 4. So I don't have to sweat the asymptote problem. The meeting point is all good. They're meeting. So what's my conclusion? Where's the discontinuity? There isn't one. There's no discontinuity. All right. How you doing? That was the roughest section. I know it took forever, but let's start here. How about, first of all, did you get k equal 5? Did you show limits? Okay, the answer to that should be also yes. Now, if you're not sure what I mean by that, then I'll clarify, but otherwise I'll move on. We good? Okay, did you get k equal 4/3 here? Okay, did you show limits? All right, if not, then show them. Does anyone have questions on either of those? Okay. Moving on. Let's see. So I have a removable discontinuity. What does that mean? Whole. Okay. This I want to show a whole graph where, first of all, f of c is defined, and second, f of c is not defined. So here I'll say c. Here it is. Here's a hole at c. What is defined mean? There is a point, but it's got to be somewhere else, like that, right? What about f of c not defined? Well, that would mean there is no place where there is a point at c, it's just a point. Check. What did you say for 8, everybody? C, it is c, okay? If the limit exists, you're looking for places where the left-hand limit equals the right-hand limit. But because it's not continuous, the point, either f at c, d, and e, or the point is not the same. And the place where that happens is at 2. The left-hand, right-hand limits are the same, but the point is not. All right? What'd you get for the last one, which I suppose is 9 eventually? B. You had to rationalize the numerator. The book I pulled this from is just crazy with terrible algebra. You had to rationalize the numerator, and then later you had to rationalize the denominator to get the square root of 2 out. Are we good there? Okay. This one. If you were to approach this one, I did say you can use a calculator. That's specifically for the top one. If you first want to ask, do they meet at 0? In other words, you want to say, does the limit exist at 0? Because the left-hand, right-hand limits are the same. This one you can do by calculator. the limit as x goes to 0 from below, what does it approach in a calculator? Either by the graph or the table. What does it look like? It approaches pi. Okay? Sine of x over x approaches 1, and then times that pi would be pi. Now that must mean that this branch here, as you approach 0 from above, you're on a minus bx. As x goes to 0 there, what does the whole thing approach? A minus bx with an x of 0 in it gives you a. Now if these two, if this is continuous, these need to meet. That implies that a must be pi. There's your first answer. Right? Now b, I guess we'll have to extract from the second part. These need to meet at x equal 1 if this is going to be continuous. And that implies left hand, right hand limits. The limit as x approaches 1 from the left, a minus bx. Now, we actually know two things now. X is approaching 1, and a, we just found, is pi. So what does that approach? Pi minus b, okay? That needs to equal the limit from the right. The limit as x approaches 1 from the right is arc of arctangent. Direct substitution, arctangent of 1. That means at what angle is tangent 1? And that is pi over 4, yeah? Now, if these two meet, then pi minus b needs to equal pi over 4. What is b then? 3/4 pi. Okay? G is continuous for all. Oh, we already did that. That's up there. I guess I had this space to work. All right. How many had no idea what I was talking about with 11? Good job. I mean, not good job. Bad job, me. Sorry about that to you. Okay. This actually is called a progressive tax. This is very much, we use a progressive tax in America. Many countries do. The more you make, the higher percent of the income you pay. And at least when I was in high school, I thought, that's not fair, man. Whatever. But after a while, I realized, yeah, it's actually kind of fair. We'll talk about that in a second. But let's talk about the math. The idea goes like this. If you make less than $30,000, you pay 5% of your income in tax. The minute you make $30,000 or more, you're going to pay 10%. You're in a higher tax bracket. Okay? Now, there's this actual weird case then in between where it hurts you to make more money. What kind of cases, do you agree 30,000 is what it's all about? Yeah? So let's talk a little below. If your income is $29,999, then what's the tax you pay? It's less than 30,000, so what percent tax do you pay? 5%. So you're going to pay 5% on what you make, and that is probably about $1,500 just shy, yeah? Maybe $1,499 or something like that, 0.95. Are you with me? I think it's something like that, ish. I'll just say that, okay? If your boss comes to you and says, man, you're doing a great job, I'm going to give you a $2 raise. And all of a sudden, you're making $30,001. Well, now, what tax bracket are you in? 10%. So what's your tax? 0.1 of 30,001. How much is your tax? I hope you can do 10% of something mentally. If you can't, go back to pre-algebra. It is $3,000.10. Okay? Now, you made $2 more, but how much more tax are you paying? Now, all of a sudden, you're paying $1,500 more in tax. So that raise just cost you $1,499. So that's kind of a bad tax structure. Any tax structure, whether you're encouraged to make less money, that's bad capitalism. Do you agree? Okay, so that's a problem. And it's because, if you were to look graphically at this, these two branches don't meet. You're jumping straight from this branch to this branch, and just $1 difference means a totally different tax. You want those to meet so that it's a smooth transition from one tax bracket into the other. Now, slope-wise, the 5% and the 10% are going to be totally different, but they need to meet. You with me? Okay. First of all, do you agree that that's linear? It's to the first power. Okay, it's linear. All right. So the question then is, how do we make them meet? Now, what I didn't get across is that I want you to keep the 10% idea. I want that second branch to be 10%, but we need to manipulate it so that line is going to meet, which means we really need to change where it is / the weightage. You follow? Okay, so let's start here. If this is linear, then the slope I know. What's the slope? Or the rate of change? 0.1. Okay. What I really need to know is how do I shift it so the branches match up and it smoothly transitions from one tax into the other, all right? Now is where we're starting to get into continuity. If I want them to meet, then the one-sided limits must be equal. Continuous, so the limit as x approaches, x, I'm already screwing up, okay? Not x, there's no x here. What? I. I approaches what? 30,000 from, let's go from below, of what? What's the function? T, okay, or T of I needs to equal the limit as I goes to 30,000 from above of T. The limit as the income approaches 30,000 from below. What's the branch from below? Now, in piecewise, you then say, all right, this is the branch I'm using. What's the lower branch? 0.05i. And that needs to equal the tax from above. What's the function for tax from above? 0.1i plus b. Okay. Now we start doing a little analytics, some calculus here. As I goes to 30,000, what is this approach? What's 5% of 30,000? 1,500. 10% is 3,000, so half of that is 1,500, right? This is 1,500, do you agree? The tax is going to get closer and closer to 1,500 as you get closer and closer to 30,000 below. So that needs to equal this guy as you're approaching. So what is 0.1i plus b as I goes to 30,000 from above? 3,000 plus b. There's that. It jumps right up to 3,000. Now we need to shift it down. B needs to be negative 1,500. And so the upper tax bracket function needs to be 0.1 times the income, take away 1,500. Now, just to verify that, that makes sense, what about that 30,001 joker now? Are they going to get screwed? Well, it's 0.1 of 30,000 minus 1,500. What's 10% of that? Well, that's $3,000.10 minus 1,500. They're going to pay $1,500.10. So their tax isn't jumping huge. It was $1,499 before. Now it's $1,500. That extra $2 and then a little more tax. Smooth transition. You follow? Okay. This, first of all, there's an error here. That was supposed to be 90, which many of you probably figured out. If you did 0 again, Think a little more critically, okay? Come on, you got to know that's not my intention. All right, so what are the radians going across? 0, pi over 6, pi over 3, pi over 2, sorry. Okay, here, what are the sign values? They start small and go bigger, don't they? Yes, so it goes 0, 1/2, root 2 over 2, root 3 over 2, all the way to its biggest value, 1. Why does sine get bigger as the angle gets bigger? Sine is defined as opposite to hypotenuse. What happens to opposite as the angle gets bigger? It gets bigger and bigger and bigger. Doesn't the opposite side get bigger and bigger and bigger? So it makes sense that sine gets bigger and bigger and bigger. Yes? Okay. What happens to the adjacent side as the angle gets bigger and bigger and bigger? It gets smaller and smaller and smaller. So the cosine values, which are the adjacent sides, should get smaller. They are 1, root 3 over 2, root 2 over 2, 1/2, and 0. Obviously, those do a little flippy flop, right? All right, tangent starts at 0. In other words, the opposite is a fraction of the adjacent. It starts as no part of the adjacent, and then it gets bigger. Root 3 over 3, 1, root 3, and approaching infinity. I can call that undefined. I use u, I don't know, whatever your teacher used, that's fine, but I use u for undefined. Cotangent then is the exact opposite, yeah? Cosecant, it's the reciprocal of sine. What's the reciprocal of 0? Undefined. 2. 2 root 2 over 2, or root 2, 2 root 3 over 3, and 1. And then secant is either you could take the reciprocal of cosine, or you could just switch the cosecant values. They go 1, 2 root 3 over 3, root 2, 2, undefined. Yeah? Okay, and picking up the pace here a little bit. For this one, I got 1. This was DNE, because the limit from the left is negative infinity, and that's not equal to the limit from the right, which is positive infinity. DNE alone is never enough. On a test or a quiz, you would probably get 1 out of 3 for just saying DNE without justifying why. Direct substitution works here. That is 4/11. On an infinite, you look at the greatest powers and how they relate. That's negative 1/3. And then the average rate of change questions are meant to lay the groundwork for tomorrow. We start the derivative tomorrow. That's 3 with work to support. This, if you simplified, you had to simplify either in this one or the next one, but if you simplified, it goes down to 2x plus h. And then this guy, if you take the limit as h goes to 0 of 2x plus h, then that goes to 2x. We just found its derivative. Okay. All right. These are those days where I think, why do I even collect this? I did the whole freaking thing with you, so how would you gotta be a real sluggish not to have this done. But there are still people that don't actually have it done. That's despite the fact that they did it all together. So please do make sure I get this by the end of the day, and if you don't get it to me by the end of the day, you're totally okay? Unless you're absent. All right. Have a good day, my friends. All right, thanks, guys. Strangers in the